Welcome to HydroMaster's CDS xDrive Service Training Video Series Part 5. So in this video we're going to cover the electrical diagrams on the xDrive. There's going to be an in-depth review of the main circuits of the xDrive electrical system. So if you wish to jump ahead to a specific section, just take note of the circuit name or number, and then you can fast forward to that place in the video. So the circuits we'll review are number 1, the recirculation pump and the throttle control power, or as Ford calls it, the SEIC. Second circuit is the SEIC Relay, which is only applicable to model years 2017 through 2019. Starting in 2020, there is no circuit 2. Circuit 3 is the power for the dash gauges. Circuit 4 is power for the freshwater pump. Circuit 5 is the power going to the recovery tank float and CR3. Circuit 6 is controller power going through CR3. Circuit 7 is the pump clutch switch and relay, CR5. 8 is the pump clutch itself, and CR5. Number 9 is the pump out pump. Circuit 10 is the parking brake interlock. Circuit 11 is the 48 volt system. Circuit 12 is the AC power system. And circuit 13, look at the controller communication wire circuit. So the first circuit is the recirculation pump and throttle, power to the throttle, the SEIC. I'm going to start with the 2020, and then we'll go back and look at the older one. So here's the Ford diagram. Shows how Ford describes it. So it's power in from the ignition to a switch, and then power into this blue wire, which they call PTO request 1. So that in 2020, that's the only thing that's needed to start the whole throttle system. It's just that one wire. This is what it looks like in our diagram. So that is circuit 1. It starts with fuse number 1. That's a 5 amp fuse. It's a green and white wire. It goes off the page in this diagram, goes to the next page. Then it goes so that green and white wire goes through the harness down to the floor behind the passenger seat. There's a plug there as it goes through the floor. It goes through that 6-pin plug, J18, P18, and then goes down, travels with the wiring harness underneath the van, up towards the front of the van on the passenger side, down to another connector, J22, P22, and that green and white wire becomes the power, the red wire, into the recirculation pump. It also, just before that plug, it branches off at J17, P17 into an orange and white wire. And that orange and white wire is the power going to the throttle control. So that continues on underneath the van up to where the throttle control wires are on the Ford, which is underneath the coolant reservoir tank. So right below that, we install this plug during the installation of the CDS. We install the plug onto the Ford wires. The Ford wires are just blunt wires sticking out. And so this is the power wire that comes in and activates the throttle control. That in the Ford's world, it's a blue wire, solid blue wire. You can also see in this diagram the wires that come out. So there's a 5 volt, which is a green and violet, comes out and goes through a resistor that we install in the harness, 1100 ohm resistor, that's what sets the speed. So we're telling the throttle control what speed we want it to run at. And then that comes back into this green and white wire. That resistor is all inside the end of this harness, and it's just behind that plug in the harness. So then just the ground circuit for the recirculation pump. The ground goes black wire through P22, J22 into a white and purple. White and purple goes back up with the harness, goes through that same plug, position 4, white and purple, and then travels back up to the dash and finds its ground in the ground position 1, which is right next to the fuse box. Between 2017 and 2019, the Ford throttle also required a relay to be involved in that circuit. This is what it looks like for those models. Still has the one trigger wire, PTO request 1, which is their solid blue wire. But there's also this relay, which we had as CR1, to provide a ground. So this blue and white wire was the ground that Ford provided to the relay through their engine control module. And then the second request, the second PTO request, was a separate wire, and that's the solid green. That's how Ford describes it. This is how we accomplished it in our wiring diagram. So we had a separate fuse number 2, and that was a 3 amp fuse. Provided power to that relay, so CR1, and the ground for the relay is the blue and white, and then the power out of that relay is the yellow. Those two wires travel again through the plug that's at the bottom of the floor. You'll also notice that this is an 8-pin plug, so because it had these 2 extra wires in there, we had to have 8 pins, whereas on the 2020 we've been able to reduce that to a 6-pin. So those 2 wires come through that harness, continue on underneath the van over to, again, to where the throttle connects behind the coolant reservoir. So there's those 2 extra wires, the blue and white, which connected to the Ford blue, and I call it a white-white, so it's supposed to be a solid or a blue wire with 2 white stripes. And then the where that other power wire, which is the same as it is on the 2020, orange and white, connected to the solid blue. The other power wire from the relay was the yellow, connected to the solid green. And then the 2 wires coming out of the engine control module going through the resistor and then back in. And you also notice that these 2 colors also changed between 2019 and 2020. So now this blue and white is now the green and violet, I believe, and this green and white is a solid green. So those wires changed. Ford changed the colors on those. So circuit number 3, this is just power for the dash gauges and dash lights. So that starts out at fuse number 3. It's black wire. That's a 5 amp fuse. Goes to the hour meter. The hour meter branches off for the light and the vacuum gauge, and then power over to the temperature gauge and the light and the temperature gauge. So that's the dash power. And then the ground post on the temperature gauge to ground location 2, and then the ground for the hour meter and the other light, circuit 3. All right, circuit 4 is the fresh water pump switch and pump. So this circuit starts out in fuse position 4. It's a brown wire. It's a 15 amp fuse. It goes to the switch in the dash, switch number 3. When that's activated, it goes out of that switch as a gray wire. That gray wire goes back along the recovery tank, and then around the back of the recovery tank and to wherever the pump-in pump is mounted on a freshwater tank. The one that's shown here is the HydroMaster version, and within that version there's actually another fuse. It's in right next to the pump. So there's 2 fuses in the HydroMaster circuit. So 15 amp one in the dash, and then this 15 amp one right at the pump. If you're using a different pump, you want to just make sure that the power requirement from the pump, this 14 gauge wire that runs back there, is going to be sufficient to carry the load, and that the 15 amp fuse in the dash is also sufficient. And then the ground for the pump out pump, or pump in pump, sorry, white and black goes over to the terminal block that's actually mounted on the recovery tank. Position 5, positions 5 and 6 are all tied together. Those are the ground positions on that terminal block. It goes out of that terminal block as a 10 gauge white wire and goes back up to ground position 1 again on the dash. So that's the freshwater circuit. So circuit 5 is the recovery tank float and the controller power relay CR-3. So that circuit starts in the fuse box at fuse position 5. That's a 3 amp fuse. It's a red and white wire. Comes out of the fuse box, goes through the harness towards the recovery tank. At the recovery tank, the red and white wire is connected to position 1 on the terminal block side of the recovery tank, and then to the white wire on the float switch. When the float switch is in the down position, you have power coming back through the green wire, connects to the brown and white. Brown and white goes back to the dash, to the fuse box. And the brown and white connects to pin 85 on CR3. And then the ground for CR3 is the white wire, goes over to ground position 2. So when the float switch in the recovery tank is down, CR3 is powered, it's active. So then the connection on the pins is between 30 and 87. But what that does, if the float switch is in the up position, so the recovery tank is full, power stops going through the green wire and starts going through the black wire. Goes to position 3 on the terminal block, turns into a red and black wire. Red and black wire comes back to the dash and powers the vacuum tank light. That's grounded. But it has also, at the same time, has cut power to CR3. Contacts on CR3 change back, and you lose connection between the wires that are going through CR3. Show you why that's important, because that's circuit number 6. This is the power going to the controllers. It goes through CR3. So again, you have recovery tank is in the float is in the down position, so CR3 is active, and you have a connection between pin 30 and 87. So that connects this blue and black wire is connected to the B plus side of the controllers. That's the positive side of the controller, so that's also connected to the positive side of the capacitor pack, which is charged up at 48 volts. So this is 48 volts coming through this blue and black wire. Comes back up to the fuse box and goes through the contacts on CR3 from 30 to 87 and turns into a pink wire. So we have 12 volt relay and 48 volts through the contact. So the pink wire provides power to the controllers. So on controllers, that pink wire comes in. So on the generator controller comes into pin 1. That powers the generator controller. And then power for the motor controller actually comes from the generator controller, pin 6. Again, the pink wire travels over and provides power to pin 1 on the motor controller. So one controller is powering the other controller. So that's circuit 6. So when the recovery tank is full, we're simply turning off the power to both motor controllers. So circuit number 7 is the pump clutch switch and relay 5. And circuit starts at fuse position 6. That's a 3 amp fuse. It's a pink and black wire. That goes down to the pump clutch switch. When the pump clutch switch is activated, so you turn the pump clutch switch on, then you have power coming out through the black wire, going back up to CR5, pin 85, and ground for CR5. So the ground for the pump clutch relay is this black and white wire. That black and white wire goes to the lower float switch in the water box. The black and white wire comes into the water box float. So when that's up, then it's making connection, so you have water in the tank, and the pump clutch is ready to be activated. And then it finds its ground at the terminal lock position 5. The pump clutch itself also uses CR3 through the contacts, but it's fused separately. So the fuse for the actual clutch is fuse number 7. Fuse number 7 is a 7.5 amp fuse. Power out of CR5 is a yellow-black wire that travels down the harness to the pump clutch, is inside the front of the machine, and the clutch is grounded internally, so that turns the clutch on. So circuit number 9 is the automatic pump out circuit. That starts at fuse position 8. And that's a 3 amp fuse. It's a red and white wire. Red and white wire comes down to the pump out switch. Switch number 4, red and white. When that's activated, it comes out as a brown wire. Brown wire goes to terminal block, position 4, and then continues on back around the back of the machine. And then what we have diagrammed here is, again, the HydroMaster pump out system. Relay in that pump out system, so that power wire is sending power to that relay. When the float switch activates that system, then power is sent actually through the float switch. Ground for the pump is run through the ground for the relay. Ground for the relay is run through the float switch. So the pump itself picks up its power directly from the battery. In the case of the xDrive, it's at that customer access point, which is on the base of the driver's seat. So there's a 12 gauge red wire comes out. We mount a circuit breaker, a 30 amp circuit breaker, close to that connection point to provide protection for that 12 gauge wire. Feeds power to the relay. When the float switch activates, then you have power going into the pump and operating the pump. That's the pump out pump circuit. Circuit number 10 is the parking brake interlock. This circuit is here to keep the machine from operating when the parking brake in the van is not set or not applied. This is necessary because the throttle control, Ford's throttle control, the SEIC, it won't activate unless the parking brake is applied. So we have to have that parking brake. We have to make sure that parking brake is applied before we can start the machine, or else the idle won't come up. So that circuit doesn't actually start at the fuse box. It actually starts at the circuit breaker on the front of the machine. So this is that ignition power source to the activation switch on the front of the machine. So when that is activated, you have power out of the switch. This orange wire comes up to CR7. Orange wire provides power to both the coil in the relay and the contacts, so 30 and 85. When the parking brake has been properly engaged, CR7 is activated. So CR7 has a ground when the parking brake is applied, and power is sent from 30 to 87. Powers the main power relay, and also powers the light in the on-off switch, the push button switch on the front of the machine. So that's if the parking brake is applied properly. If the parking brake is not applied, well, here's the ground. So this is the ground for that parking brake circuit, which is the white and purple wire. That white and purple wire goes down and connects to the actual parking brake switch, which is between the seats. So that's where that relay gets its ground. It's from that parking brake. But if it's not applied, so CR7 does not have a proper ground, then you have power going between 30 and 87A. That's this white wire that comes down and actually powers this flashing circuit. So this flashing circuit is now providing power to the light in the push button switch. So the push button switch will flash, but also at the same time it's providing power. Next slide. It's providing power to the main control relay, which is CR12. So this is the power coming back up and powering CR12. So it also flashes all the lights and everything in the dash. And at the same time, it keeps the machine from starting. So in a nutshell, that whole circuit, if the parking brake is not applied, flashes the lights in the dash and keeps the machine from operating. So that's the parking brake interlock circuit. So circuit number 11, we'll look at the 48 volt DC circuit that charges the capacitor pack and provides power, initial power to the controllers. So that circuit starts with van ignition power. So we're taking that from the circuit breaker, this red 18 gauge wire, provides power to the charge circuit that's on the capacitor pack, provides power to this 12 to 48 volt converter that's mounted right next to the capacitors. And then the ground for that comes out of the converter. 12 volt ground comes out of the converter, provides ground also for that CR13 relay, and that ground comes back to ground position 2. When the converter is active, so the van is running, the ignition's on, the van is running, machine is off, the converter is active, converting the 12 volts into 48 volts. The positive side comes out, the yellow wire goes to through the contacts in CR13, goes through a resistor. This is either a 27 ohm or a 30 ohm resistor. We've used both. One just is a little faster than the other. We do that though to actually reduce the current down to about 2 amps. So we're charging the capacitor pack at about 2 amps, and that's just to protect the converter. Converter is good for about 7 amps or so. So that's the positive side, charging capacitors. Negative side of the capacitor pack comes out through a black wire. This is the charged part of the capacitor pack, black wire, and then goes back into the negative side of the 48 volt side of the converter. There is a 7.5 amp fuse in that negative side wire. It's just a little wire that goes from the front of the capacitor pack down back to the back of the capacitor pack where the converter is. So there's an inline fuse in there with a 7.5 amp fuse. That's just to protect the converter from any stray voltages, because the capacitors do have the ability to provide or produce some high load situations. So we protect the wires coming in the charge circuit. So this is all happening when the ignition is on in the van and the machine is off. We're charging up the capacitors. Charge it up. We'll eventually get to 48 volts. It takes about 8 minutes to go from completely discharged capacitor pack up to a fully charged capacitor pack. Then that is providing that initial power through a red and black 4-gauge cables up to, and they're connected to the front of the controllers to B plus and B minus right on the bus bars. So that's providing that 48 volt power to the controllers. And then we saw in a previous circuit, then the power can be taken off of that to switch the controllers off and on. When the machine is started, power is sent to CR13, so the relay that's on the capacitor pack, and it changes the contacts, so it breaks contact on the positive side of converter, and that the power to activate CR13 is coming from the fuse box, and that's an orange and white wire connected right to the main power side of the fuse box. So that is the 48 volt charging circuit, and so that's how we go from 12 volts to 48 volts. So circuit number 12 is, we'll look at just briefly at the AC side of the controllers. So this circuit, so anytime the generator is turning, so anytime the engine on the van is on, the generator is turning, it's producing AC power, 3-phase AC power out of the generator on these 3 cables, 3 1-aught cables. They're actually orange cables, but we put markers on them. So M1 or position 1 is a blue. There's a blue marker on that. The middle one, position 2, is a yellow wire, and position 3 is a black marker on an orange wire. So we break two of the phase cables, two of the legs, the blue M1 phase cable and the black M3 phase cable. Those are both go through a set of contactors that are right underneath the radiator in an enclosure. So when the machine is turned on, both of these solenoids are activated. The contact is made, and then you have power, AC power, traveling through all three legs up to the generator controller. They're also designated as M1, M2, and M3. M1 is that blue marker, M2 is the yellow, and M3 is the black. So that's how we get power, three-phase AC power to the controller. So anytime the generator is spinning, we're producing the AC power. When we turn it on and we start requesting for the motor to turn, then the generator controller is receiving the AC power. It's converting it to DC power because the controller needs DC power. It thinks it's running on a battery. So the motor controller takes that 48-volt DC power and converts it back to AC to drive the motor. So again, we have M1, M2, M3, so the three-phase cables, same color schematic, blue, yellow, and black, connected to the motor positions 1, 2, and 3. So that's how we go from AC generated power to DC supplied power, and then back to AC supplied power to the motor. Circuit 13. So the controllers also have to communicate with each other since they're tied together. The controller area network. That's the communication protocol that they use to communicate together. It's often referred to as a CAN, C-A-N network. So those wires are coming out of the controllers. There's a set of wires. So this is a two-wire communication. There's a purple wire and a green wire. Those are the communication wires. They're twisted together. So as soon as they come out of the plug, you'll see that they're twisted. That's to try and keep any interference, outside interference from interfering with the signal. So the green side of that communication starts on pin 24, and the generator controller comes out, is connected to another green wire that goes back to the motor controller, and that's pin 27. It's also connected to the computer access port, which is that little computer port right above the fuse box. And then there's another set of CAN wires coming out of the generator controller. And these are just to drive the tachometer. So out of pin 27, the green wire coming out, going to the tachometer. And that goes over the tachometer and is connected to the first plug position, number 2. That's what drives the signal to the tachometer. So the other side of that is the purple wire. It starts out at pin 13. The generator controller again goes to a connector where it breaks off and goes back to the motor controller, and that's pin 16, and connects again to the computer port. So it's a loop. CAN wiring also always has to be in a closed loop, and at the computer port, since there's no connection between the purple and the green wires, we have to make that connection before it gets there, and that's what this little 120 ohm resistor is. That's referred to as a terminating resistor, so that keeps the loop, the CAN loop, closed, and so that the CAN wiring is intact. If it's not intact, then you start getting communication errors and the machine shuts down. And then that's also connected to the tachometer, so that's part of the CAN network, and that's that first position, or first plug, position 3. So that's the CAN network, and that is all of the main wiring circuits on the xDrive. If you have any additional questions or need any more clarification on those, please hesitate to contact HydroMaster Service Department.